I sat down in the car to learn to drive. My feet didn't reach the pedals, nor could I see over the steering wheel. I'm 5'2" for reference. After adjusting my seat to see and reach everything, my head might as well have been touching the windshield. I soon realized this was not an isolated issue, nor just me being anxious. Short-statured drivers are 47% more likely to be severely injured and 17% more likely to die in a car crash. This discrepancy is due to insufficient vehicle safety guidelines as a result of continued use of physical crash test dummies with limited biofidelity. In my project, human participants were measured to get a pool of actual seat positions, focusing on the distance between the top of the steering wheel and the nose, the middle of the steering wheel and the chest, and the pelvic angle. Simulations of a 40-mile-per-hour frontal collision were run for all participants under 170 centimeters using nonlinear finite element analysis, focusing on the interaction between dummy positioning and the seatbelt and steering column with an airbag. No other structural safety elements were included in the vehicle sled model. Simulation data was analyzed to extract chest deflection, acceleration, and severity index, as well as head acceleration and injury criteria. This data was compiled into a composite injury score, a method developed to classify total injury score by adding up points from each injury output. A total of 145 simulations were run, and after performing an optimization simulations to all short-statured drivers, changes to the pelvic angle, specifically a pelvic angle between 112 and 120 degrees, while keeping the head distance as close as possible to the baseline, proved to have the most significant positive change on the injury severity score. For the drivers whose optimized positions exhibited improved injury severity scores, the overall effect was a 39% reduction in crash severity.